Welcome. Settle in. You do not need to go anywhere tonight. You do not need to do anything except let the weight of the day begin to loosen from you, one breath at a time, one small surrender at a time, until you are just a person lying still in the dark, which is all you need to be. We are going somewhere tonight that requires no luggage, no preparation, no effort of any kind on your part. We are going to the ground, not across it, not above it, through it, down into it, into the part of this planet that has been frozen since long before anyone now alive was born, since long before the earliest cities were built, since long before the species we call human had developed enough language to name what cold even was. There is a zone beneath the surface of the earth, beneath the tundras of Siberia and the wide plains of Alaska and the boreal forests of northern Canada and the high plateaus of Tibet, where the temperature has not risen above 0 degrees Celsius in thousands upon thousands of years. In some places, it has not done so in over 1 million years. The ground there is not simply soil and rock. It has been transformed by cold into something else entirely, something harder, stranger, and vastly more significant than its plain appearance would suggest. Scientists call it permafrost, a word that sounds almost too ordinary for what it actually describes. We will spend the next several hours in his company, and I think by the end of the night, you may find that the ground you walk on has become a different kind of thing to you, larger, older, more patient than you could have imagined. If this kind of slow and wondering exploration through the deep and quiet corners of the natural world is something you find useful for sleep, I am very glad you are here. Please consider subscribing if you have not yet, and leave a comment if you feel like it. Tell me where in the world you are right now, what season it is outside your window, what the weather is doing above the ground where you live tonight. Now find whatever position is most comfortable for you. Let your hands fall open. Let your jaw go soft. Breathe in slowly, as if you are breathing down into the very base of your lungs, and then let the breath leave without any effort at all. We are going underground. Most of us, most of the time, do not think about the ground. We stand on it, walk across it, plant things in it, build on it, occasionally dig into it when something needs to be repaired or buried or planted. But we do not think about it as a place with its own interior life, its own ancient history, its own ongoing processes that have nothing to do with us and never did. The ground, to most of us, is a surface, a beginning point, the thing from which everything else extends upward. But this is a very thin way of understanding something very deep. The ground is not simply a surface. It is a vertical world, extending downward through layers of increasing age and transformation, topsoil laid down over centuries of leaf fall and decomposition, subsoil from earlier geological periods, bedrock laid down before complex life existed on this planet at all. And in the northern portions of the world, in the great circumpolar band of land that rings the Arctic and extends deep into Asia, North America, and Northern Europe, there is a layer in that vertical world unlike any other, a layer that has been cold and is still cold and has been cold for so long that the cold has become a fundamental property of the Earth itself in those places, rather than simply a seasonal condition. This layer is permafrost, and the first thing to understand about it, the thing that separates it from ordinary frozen ground, is the timescale. When water in the soil freezes in winter and thaws in spring, that is the active layer, the seasonal surface. It is temporary. It participates in the normal rhythm of the year. Permafrost lies beneath that active layer, and it does not participate in the rhythm of the year at all. It operates on a different kind of time entirely. Permafrost is defined, technically,
as ground that has remained at or below 0 degrees Celsius for at least 2 consecutive years. But that is just the threshold, the definition, the beginning of the story. The reality is that most permafrost in the world has been frozen not for 2 years, but for thousands, tens of thousands. In the deep frozen heart of the Siberian lowlands, the permafrost extends downward for over 1 kilometer and has been frozen for periods that approach or exceed 1 million years. Let that sink in gently, the way a slow thought sinks in when you are already tired and your mind is soft at the edges. 1 million years of continuous cold. The civilization you were born into is perhaps 6,000 years old at the very most, if you count from the first cities and the first writing. The species you belong to has existed in its current recognizable form for perhaps 300,000 years and was doing interesting human things for only a fraction of that. Agriculture, the invention that made cities possible, that made the last few thousand years of accumulated human knowledge possible, is roughly 12,000 years old. The permafrost that underlies the Siberian plain was already ancient when your most distant nameable ancestor planted the first seed in the first field. It was already ancient in the way that geological time is ancient, not in the way that a cathedral is old, or a language, or a tradition, but old in the way that a mountain range is old, or an ocean basin, or the orbit of a planet. Old enough that the word old feels somehow insufficient. The permafrost covers approximately 1/4 of all land in the Northern Hemisphere. That is not a small footnote. That is a vast, continuous territory larger than Europe and North America combined, all of it underlined by this frozen zone, all of it shaped by its presence, all of it dependent in ways we are only beginning to fully understand on the continued integrity of that cold subsurface layer. The tundra ecosystems of the high Arctic, the spare, wind-raked landscapes of sedge grass and low shrub and shallow ponds, the landscapes that look empty to human eyes but are in fact extraordinarily dense with life during the brief summer months, all of these depend on the permafrost below them. The permafrost acts as a floor. It is impermeable to water. It prevents the surface moisture from draining away, and so the surface stays wet even in landscapes that receive very little rain, and the wet surface supports the mosses and sedges and small flowering plants that support the insects, that support the birds, that support the foxes and bears and caribou and all the rest of the visible Arctic life we think of when we think of those places. Remove the permafrost and you drain the tundra. You change the entire character of the ecosystem from the bottom up. But the permafrost does more than anchor an ecosystem. It is an ecosystem, or rather, it is the frozen record of all the ecosystems that have ever existed in these places, laid down in layers over geological time, each layer a snapshot of a world that no longer exists anywhere above the surface, but which still exists, intact and preserved, in the cold below.
There is a kind of discovery that happens in permafrost regions that is unlike any other kind of discovery in natural history. It is a discovery not of fossils, not of impressions, not of outlines or shadows or traces, but of the original things themselves. Tissues, cells, molecules, last meals, last breaths, preserved not by transformation into stone, but by the simple, absolute application of cold. Cold that stopped the clock on organic decay so completely that what was frozen at the moment of death is in many cases still there, still recognizable, still carrying within its chemistry information about the world it came from. The most iconic of these discoveries are the mammoths, woolly mammoths, the great, slow, cold-adapted relatives of modern elephants that walked the Pleistocene tundra in enormous herds before disappearing around 10,000 years ago, have been emerging from the Siberian permafrost for as long as people have been digging in that ground. The local indigenous peoples of northeastern Siberia knew about them long before European scientists did.
They called the bones and tusks the remains of a giant underground creature, a subterranean animal so large that the tunnels it made beneath the soil caused the earth above to tremble and subside. The tusks were used for trade, sold to craftsmen who worked ivory, prized for their quality, which was often superior to freshly harvested elephant ivory because the cold had kept the material dense and firm. The mammoths were, practically speaking, a natural resource, a buried treasure that the frozen earth gave up slowly and unpredictably, one melting bank or one river erosion at a time. But the scientific value of the mammoths was never really in the tusks, it was in the flesh. Because the permafrost mammoths are not fossils. A fossil is the result of a completely different process, a process of slow mineral replacement in which the original organic material is dissolved and replaced, molecule by molecule, by minerals in groundwater, until what remains is chemically rock, but structurally the original creature. A fossil preserves shape. A permafrost specimen preserves the thing itself, the actual cells, the actual proteins. In some extraordinary cases, the actual DNA, or enough of it to reconstruct meaningful portions of the genome. The mammoth, called Luba, found in 2007 in the Yamal Peninsula of Russia by a reindeer herder named Yuri Hudi, was 1 month old when she died, approximately 42,000 years ago. She was found with her eyes closed, her trunk curled gently, her skin intact and pale brown, her internal organs still present in the body cavity. When scientists examined her, they found her musculature in a condition that allowed them to study the proteins directly. They found undigested milk in her stomach, the last meal she took before she died, still present and still chemically identifiable after 420 centuries. They found, trapped in her trachea, the clay that had apparently suffocated her when she fell into a muddy hollow, which explained both the manner of her death and the extraordinary quality of her preservation. She had been sealed almost immediately upon dying, before decomposition could begin, then frozen solid and held in that state without interruption for tens of thousands of years. What does it mean to hold something that perfectly for that long? When you fall asleep tonight, your body will enter a state of reduced function, heart rate slower, temperature slightly lower, consciousness temporarily gone. But you will wake in the morning recognizably yourself, changed by perhaps 8 hours. Luba was changed by 42,000 years, and the change was so small that the milk in her stomach still told her story. This is what the permafrost does. This is the nature of the cold that lies beneath the northern ground, not merely the absence of warmth, but the active preservation of everything warmth would otherwise dissolve. The woolly mammoth cave bears have been found with their claws intact, their fur still showing color. Ancient cave lion cubs, barely a week old at the time of death, have been recovered with their whiskers attached to the skin of their muzzle, their paw pads still soft and pliant, their sealed eyes still carrying the expression of newborn sleep. Specimens of Pleistocene wolves have been found that still show the texture of their fur and the shape of the muscles around their jaws. A foal recovered in Yakutia in recent years still had the pale, soft hoof covering that foals are born with and shed within the first weeks of life, a detail so transient, so specific to a developmental moment that its preservation speaks to a death so rapid and a freezing so immediate that the animal was essentially sealed in the ground between one heartbeat and the next. And the preservation is not limited to large animals. Perhaps the most quietly remarkable of all the permafrost discoveries is the story of a small flowering plant called Silene stenophylla, a modest little herb with narrow leaves and small white flowers that grows on the open steppe today, unremarkable in appearance, not the kind of thing that would stop most people's attention. But seeds of this plant, buried in the permafrost of northeastern Siberia at a depth that placed them in material approximately 30,000 years old, were recovered by scientists and subjected to a careful, patient process of rehydration and warmth. The seeds germinated, not all of them and not easily, but some of them. They pushed out roots, they grew stems, they developed leaves, they flowered, they produced viable seeds of their own. 30,000-year-old plants returned to life by the application of warmth after a dormancy so long that the entire anatomically modern human species had not yet spread to every continent when those plants went to sleep. They did not know they had been asleep. They simply grew, the way plants grow, as if nothing unusual had happened. There is something almost unbearably beautiful in this if you allow yourself to sit with it. The idea that life is not so fragile as we tend to think, that the basic instructions for existence, the chemical program encoded in the seeds of a small white flower, can survive 30,000 years of cold darkness and emerge still functional, still knowing what to do, still capable of sunlight and growth and the production of new life. It is a fact about biology. It is also a fact about the nature of patience that seems to exceed anything we usually mean by that word. But the permafrost holds something else, something far less visible and far more consequential for the world in which you and I are currently trying to sleep. It holds carbon. Carbon in almost incomprehensible quantities. Over millions of years, the Arctic was not always the spare landscape it is today. Warm periods alternated with cold. Forests grew where tundra now stands. Grasslands stretched where only sedge and moss exist today. Each time a warm period ended and the permafrost advanced, whatever was growing on the surface, grass, shrubs, trees, the accumulated biomass of complex ecosystems was sealed into the frozen ground before it could decompose. The carbon in those organisms was locked in, held in suspension, taken out of the active carbon cycle and stored in the Earth's own deep cold refrigerator. This happened repeatedly across many glacial and interglacial cycles, each cycle adding another layer to the frozen archive, each layer containing the carbon of another brief warm world that ended in cold. The result of this accumulation over geological scales is a quantity of carbon stored in the permafrost that scientists currently estimate at approximately 1.5 trillion tons. 1.5 trillion tons. The entire atmosphere of the Earth currently contains roughly 850 billion tons of carbon. The permafrost holds nearly twice that, nearly twice the total atmospheric carbon of the planet, locked in cold, held in the frozen ground, kept by the same reliable cold that kept Luba's last meal and the ancient seeds of the white steppe flower. As long as the cold holds.
Before we come to what is happening to the permafrost now, I want to take a little time in the landscape above it. Because permafrost is not merely a geological phenomenon, it is a landscape-shaping force. It determines the character of the surface above it in ways that are visible and strange and often quietly beautiful to those who know what they are looking at. In the summer months, the brief, light-saturated summer of the high Arctic, where the sun barely sets and the warmth is intense though short-lived, the surface of the permafrost landscape has a character unlike anything in temperate or tropical environments. The active layer, the thin zone of soil above the permafrost that does thaw seasonally, becomes waterlogged. Because the permafrost below is impermeable, rainwater and snowmelt have nowhere to drain. The landscape becomes a vast, shallow, intricate wetland, dotted with thousands upon thousands of small ponds, threaded with streams that freeze and thaw and redirect themselves from one year to the next, covered in a low and extraordinarily diverse carpet of mosses, lichens, sedges, and small flowering plants that produce an impossible brilliance of color in the short window between the snow's departure and its return. This is the tundra, one of the least understood and most underappreciated biomes on the planet. To an eye trained on forests and meadows and coastlines, it looks empty, flat, brown or gray, or in summer briefly green, stretching to a horizon that seems to promise nothing. But spend time in it, and it reveals itself as something entirely different. Walk carefully, and the ground beneath your feet is not flat, but intricately patterned, shaped by the freeze-thaw cycles of the active layer into geometric structures called patterned ground that look, from above, like the scales of an enormous reptile or the surface of a brain. These polygons are formed by the repeated expansion and contraction of ice in the soil, which over time pushes stones and fine materials into roughly circular or polygonal configurations that can persist for centuries. The tundra organizes itself. In the absence of the digging and tilling and rearranging that humans bring to other landscapes, the natural forces of cold and thaw create their own geometry, patient and precise. There are also the pingos, dome-shaped hills that rise from the flat tundra with a distinctiveness that seems almost deliberate, as if something decided to push a small mountain up from below. A pingo is exactly what that sounds like. It is a dome of earth pushed upward by an expanding lens of ice forming in the permafrost beneath it. The ice grows from year to year, lifting the overlying soil in a slow, inexorable heave. Some pingos are only a meter or two high. Others rise to 40 meters or more, visible for considerable distances across the flat tundra, sometimes crowned at their summit with a crack where the expanding ice has finally split the skin of the hill. They are, in geological terms, young and temporary. They form over decades or centuries, and they collapse back into the landscape when the ice at their core eventually melts. But while they stand, they are genuinely strange. Quiet, grass-covered hills in a landscape that should, by all logic, be flat, the visible evidence of forces working slowly in the dark below. And then there is the permafrost's most dramatic surface expression, the thermokarst. Thermokarst is what happens when the permafrost begins to thaw. The word means warmth-shaped, and it describes the particular kind of landscape collapse that occurs when ice-rich frozen ground melts and the structure that the ice was providing disappears. Ice takes up more volume than water. When the ice in permafrost melts, the ground above it settles, subsides, collapses into the void that the ice occupied. The result is a terrain of irregular depressions and hummocks, of tilting trees and buckled ground, and lakes that appear suddenly where no lakes were before. Trees in thermokarst areas are called drunken trees. Their root systems, once anchored in firm frozen ground, find themselves in suddenly unstable material, and they begin to lean in every direction without any apparent cause from the surface, like partygoers who have had too much and cannot quite maintain vertical anymore. I want you to imagine, if you can keep your eyes from closing for just a moment longer, what a forest of drunken trees looks like at sunset in the Siberian autumn. The light is golden and low and stretched out across the landscape because the sun is barely clearing the horizon before it sinks again. The ground between the trees is a patchwork of russet and amber, mosses and low shrubs turning their autumn colors. And in every direction, the trees lean, some toward you, some away, some listing sideways with a gentle insistence, their roots still trying to hold in ground that has become quietly unreliable. It is uncanny. It is beautiful. It is the permafrost communicating something to the surface in the only language it has, the language of what happens when cold retreats. The permafrost speaks through landscape. It speaks through the geometry of patterned ground and the upheaval of pingos and the collapse of thermokarst terrain. It speaks through the presence or absence of wetlands, through the character of river channels, through the depth and clarity of Arctic lakes. It has been speaking this language continuously as long as it has been cold, a language that the indigenous peoples of the Arctic learned to read over thousands of years of living with it, and that Western science is only now beginning to understand with the depth and attention the subject deserves.
Long before scientists named permafrost or measured it or drilled cores through it to read its secrets,
People were living on top of it, living with it, building their understanding of the world around its presence and its properties in ways that made them experts in everything we are only now, with great effort and sophisticated instruments, beginning to learn. The Yakuts of northeastern Siberia, the Inuit and Inupiat and Yupik of Arctic North America and Alaska, the Nenets and Evenki of the Russian North, the Sami of Scandinavia. These peoples developed over millennia a relationship with the frozen ground that was practical and intimate and encoded in their languages, their architecture, their agricultural and hunting practices, their understanding of weather and season and landscape. The Yakut word for the ground itself contains within it a reference to the depth at which frost persists, because in a landscape where permafrost determines almost everything about the surface you can live on and farm and build, the distinction between frozen and unfrozen ground is not an academic one. It is the distinction between a building that stands and one that sinks, between a cellar that preserves your meat through the summer and one that floods. The use of permafrost for refrigeration is one of the most elegant examples of technology born from intimate environmental knowledge. In Yakutia, people dug into the permafrost to create underground cellars, not sealed with ice or cooled mechanically, but simply embedded in the natural cold of the earth, which maintained a temperature below freezing year-round. Food stored in these natural refrigerators kept indefinitely. The permafrost was understood not as an obstacle or a hazard, but as a resource, a free, perpetual, reliable refrigeration system that asked only that you dig deep enough to access it and seal the entrance carefully enough to prevent the summer warmth from penetrating. Contemporary versions of these underground permafrost cellars still exist in parts of Siberia and Alaska. Some families have maintained the same cellar for generations, each generation deepening and maintaining the structure, the cold holding faithfully through decade after decade. The architecture of permafrost cultures reflects the same intimate understanding. Traditional building on permafrost required knowing that the warmth of a house placed directly on the frozen ground would thaw the permafrost beneath it, would soften and destabilize the very foundation on which the building stood. The solution, developed independently across multiple Arctic cultures, was to elevate the building, to build on stilts or on raised platforms that allowed cold air to circulate between the floor of the building and the surface of the ground, so that the warmth of the interior never reached the frozen layer and the foundation remained firm. Modern buildings in permafrost regions that do not respect this principle have a discouraging tendency to sink slowly and unevenly into the ground as the permafrost beneath them melts, tilting at the corners, cracking around the windows, eventually becoming uninhabitable. The buildings that were designed by traditional knowledge, that were placed and elevated in ways that respected the character of the ground, stood for generations. There is a kind of wisdom here that deserves unhurried recognition, the wisdom of people who understood, without thermometers or geological surveys or permafrost maps, that the ground beneath them was not simply ground, that it had a particular nature, a particular behavior, a set of properties that demanded respect and careful attention. They learned this through generations of observation and accumulated experience, through the slow, patient accumulation of knowledge that happens when people live in the same place long enough to learn its secrets. And what they learned about the permafrost was, in essence, the same thing that contemporary scientists are now learning with much more sophisticated tools: that it is old, that it is deep, that it is in some fundamental way the foundation on which everything else in that landscape rests, and that if you understand it and work with it rather than against it, it will serve you in ways almost nothing else can. Permafrost is many things. It is a landscape-shaping force, it is a resource, it is a foundation, it is a preservation system of extraordinary fidelity. But among all of these things, the one that I find most quietly astonishing, the one I keep returning to in the long dark of nights like this one, is its function as an archive. Not a metaphorical archive, not an archive in the loose sense in which we sometimes say that a landscape or an ecosystem preserves some record of the past. A literal archive, a stratified, sequential, retrievable record of the conditions, organisms, atmospheres, and events of the past, laid down layer by layer over geological time and held in readable condition by the simple, absolute fact of continuous cold. When scientists drill a permafrost core, a cylindrical sample of frozen ground extracted by an instrument that descends vertically through the layers of the past, what they retrieve is a physical object that encodes time in the way that the rings of a tree encode time. Each layer corresponds to a period. Each layer contains the pollen and spores of the plants that were growing at the surface when that layer was deposited. It contains the remains of insects, sometimes whole insects, preserved in the same astonishing detail as the mammals, their compound eyes still reflecting under the laboratory light. It contains seeds. It contains fungal spores. It contains the chemical signatures of the atmosphere as it was during that period, the isotopes that tell us about temperature and precipitation, the trace gases that tell us about what was burning and what was growing, and how the whole planetary system was functioning at that moment. Ice cores drilled from the glaciers of Greenland and Antarctica have given us climate records extending back nearly 1 million years, and these are among the most scientifically valuable objects in the world. Permafrost cores are in some ways even richer because they add the biological dimension that ice alone cannot provide. An ice core tells you about temperature and atmospheric chemistry. A permafrost core tells you about what was living, which plants, which insects, which soil bacteria at each stage of that record. It gives you not just the climate, but the ecosystem, not just the conditions, but the life those conditions supported. This means that the permafrost contains something genuinely extraordinary, a continuous biological record of the Arctic across the entire span of the Pleistocene epoch, across all the advances and retreats of the glaciers, all the warm interglacials and cold glacial maxima, all the dramatic reorganizations of species distributions and ecosystem types that accompanied those shifts. We can read in the permafrost cores what the tundra looked like during the last ice age maximum, when so much of the world's water was locked in glaciers that sea levels were over 100 meters lower than today, and much of the shallow Arctic shelf was dry land, covered in a vast steppe tundra ecosystem that no longer exists anywhere on Earth. We can read what grew there. We can read what died there and was sealed into the cold. We can read the transition as the glaciers retreated and the world warmed and the mammoths disappeared and the forests moved northward into what had been open grassland. The permafrost archive does not require interpretation in the way that most historical records do. It does not need to be translated from a dead language or decoded from a damaged text. It simply needs to be cold enough to hold and warm enough in the laboratory to give up its information to the people reading it. It is, in this sense, the most literal and direct record of the past that the natural world has produced. Not a trace or an impression or a symbol, but the thing itself, held in the dark below the surface with a patience so absolute and so impersonal that it almost defies comprehension from the inside of a human life. There is pollen in the permafrost of northeastern Siberia from flowers that no human has ever seen blooming. There are seeds from plants whose surface populations went extinct before the first stone tool was made. There are ancient viral particles, viruses so old they are referred to as giant viruses, from lineages that predate the most ancient identifiable human ancestor, that have been identified in permafrost samples, still structurally intact, still carrying genetic material, still potentially capable of function if the conditions were right. This last fact has attracted some attention in recent years, and not entirely comfortable attention for reasons we will come to. But for now, simply hold the image. Something so old it predates the genus Homo, preserved in the cold below the Siberian tundra, waiting with the same patience as everything else the permafrost holds.
There is something that permafrost scientists know and carry with them when they go to work in the morning, and set down, most of the time, when they come home in the evening, because a person cannot carry it continuously and remain functional. It is not a secret, it is not a prediction, it is a measurement. A set of measurements accumulated over decades, showing a consistent and accelerating trend that has no ambiguity in the data and no comfortable interpretation. The permafrost is warming. This is happening across all permafrost regions. In northern Alaska, ground temperatures measured at monitoring stations have risen by between 1 and 2 degrees Celsius since monitoring began in the 1980s. In parts of Siberia, the rates are higher. In some high-elevation permafrost on the Tibetan Plateau, the warming is faster still. The Thaw front, the boundary between frozen and unfrozen ground, is moving. In many locations, it is moving downward, as the permafrost that once extended close to the surface retreats to greater depths. In others, it is retreating laterally, with areas that were once continuous permafrost becoming discontinuous, interrupted by patches of unfrozen ground that expand from year to year. And in the warmest and shallowest permafrost regions, the frozen layer is disappearing altogether, leaving behind it a landscape that has changed its fundamental character and must now reorganize itself around the absence of the foundation that held it for millennia. The Thermokarst that I described earlier, that distinctive and somewhat surreal collapse terrain of subsiding ground and tilting trees and newly formed lakes, is expanding. Rapidly in geological terms, dramatically in some locations, even in human terms. There are places in Siberia and Alaska where the rate of permafrost thaw has visibly transformed the landscape within the lifetime of individual people who live there. People who remember as children walking on firm ground and who now stand at the edge of new lakes that appeared in their adulthood, lakes that did not exist when they were young, lakes that are growing steadily year by year as the ice in the permafrost below them continues to melt. The landscape of their childhood is becoming different ground. The consequences of this thaw operate at several scales simultaneously, and it is important to hold them all at once without flattening the story into a single headline. At the local scale, the thaw in permafrost is simply transforming the land. Roads built on permafrost are buckling and sinking as the foundation they were built on loses its integrity. Buildings, bridges, and infrastructure across the Arctic are requiring expensive and often unsuccessful remediation as the ground beneath them changes. In some communities in Alaska and Russia, entire villages built on permafrost are being discussed for relocation. The ground is no longer reliable enough to build on, and the cost of maintaining infrastructure in subsiding, unstable terrain is becoming unsustainable. These are real consequences affecting real communities in a time frame that is immediate and not theoretical. At the ecosystem scale, the changes are more complex. The Thermokarst lakes that are forming as the permafrost thaws create new wetland habitats. In some regions, this temporary increase in wetland area is actually increasing local biodiversity as waterfowl and wetland-adapted species expand into the new terrain. But the lakes are temporary.
As the thaw continues and the permafrost below the lakes disappears entirely, the lakes drain, leaving behind a very different landscape than the one that existed before the permafrost was present. The sequential transformation from stable tundra to Thermokarst lake to drained terrain passes through phases of apparent ecological richness on the way to a different kind of system, one that is not necessarily less productive, but that has lost much of what made the permafrost tundra distinctive. And at the global scale, the scale that climate scientists and atmospheric chemists and anyone concerned about the trajectory of the planet's temperature over the coming century must engage with, the thawing permafrost is beginning to release its carbon.
When organic material that has been frozen for thousands or hundreds of thousands of years begins to thaw, it does not simply sit there unchanged. It encounters warmth. And warmth is what bacteria and fungi and all the microscopic agents of decomposition have been waiting for, patiently, in the same way that everything in the permafrost waits patiently, but with the fundamental advantage that they are alive, and alive things can act when conditions permit. The ancient carbon in the thawing permafrost begins to decompose. The microbes that were present in the soil when it froze, some of them dormant for timescales almost beyond comprehension, some of them revived from what appears to be a state of suspended animation by the return of warmth in liquid water, resume their work. They break down the ancient organic material, they consume it, and in consuming it, they release it as carbon dioxide where the thaw is in well-drained aerobic conditions, as methane where the thaw is in waterlogged anaerobic conditions, as in the bottoms of Thermokarst lakes. Methane is, by weight, a far more potent warming agent than carbon dioxide over short timescales. It is, in climate terms, a faster and more urgent problem, and the Thermokarst lakes of the Arctic are producing it in quantities that have surprised researchers. In some of these lakes, the methane production is visible, literally visible. Bubbles rise from the sediment at the bottom and break the surface of the water in a continuous, lazy effervescence, as if the lake is gently carbonated, as if something deep below is breathing out, releasing slowly the long breath it has been holding through the entire span of human civilization. In winter, when the surface of these lakes freezes, the methane bubbles are captured in the ice and held there until the spring thaw releases them. Researchers who have studied these lakes for decades have described finding the ice covered in circular patches where bubbles of ancient methane are frozen in mid-release, each one a small, sealed cell of gas from a world that ended thousands or tens of thousands of years ago, waiting to be released into a world it never knew. This is the feedback loop that climate scientists discuss with the particular careful gravity that characterizes communication about something consequential. The mechanism is simple to state and complex in its implications. Warming thaws permafrost. Thawing permafrost releases carbon. Released carbon warms the atmosphere further. Warmer atmosphere thaws more permafrost. Each step amplifies the next. The loop, once begun, has its own momentum. The crucial question, the one that researchers are working very hard to answer with the necessary precision, is how quickly this feedback operates and how large it will ultimately become. There is genuine scientific uncertainty here, not the manufactured uncertainty of interests that prefer inaction, but the honest uncertainty of people who are trying to quantify a system of enormous complexity with the best available tools. The amount of carbon that permafrost will release into the atmosphere over the coming century depends on how quickly the Arctic warms, which depends on global emissions, which depends on human decisions not yet made. It also depends on local factors, the depth and ice content of the permafrost, the drainage of the terrain, the presence or absence of snow cover,
the thickness of the active layer above, that vary enormously across the permafrost zone and that introduce real uncertainty into any global estimate. What is not uncertain is that the process has begun. The measurements show it. The methane bubbling from the Thermokarst lakes shows it. The tilting buildings and the new lakes and retreating permafrost boundaries all show it. The frozen archive is opening, slowly, unevenly, in ways that are still manageable and in ways that are not, but opening. There is one more thing the warming permafrost holds that deserves careful attention. Deep within the ancient ice, researchers have found ancient pathogens, remnant viruses and bacteria from ecosystems that no longer exist on the surface. Most of these are of no concern. Most ancient microbes cannot survive thaw or have living hosts to infect or are harmless in any practical sense. But in 2022, French scientists revived several strains of ancient viruses from Siberian permafrost, viruses of types that affect single-celled organisms, not humans, demonstrating that some ancient pathogens retain infectious capacity after tens of thousands of years of frozen storage. This is not, as of current scientific understanding, a near-term risk to human health, but it is a reminder that the permafrost archive contains more than we have inventoried, and that some of what it contains is alive in the functional sense of alive, capable of activity when the conditions allow. We are, in some ways, only beginning to understand what we are releasing when we release the cold.
Somewhere in the Siberian lowlands, right now, there is a team of scientists who have spent several months in temperatures that make most of the equipment they brought with them behave in ways it was not designed for. They are drilling, slowly, carefully, extracting cores of frozen ground that come up in long cylindrical sections wrapped in the gray and brown and occasionally brilliantly colored layers of the past. Each core section is labeled with its depth, its location, its extraction date. Each one is wrapped in protective material and stored in a portable cold storage unit to prevent any thaw during transit. Eventually, these cores will arrive in a laboratory where they will be described, photographed, sectioned, analyzed. Some will go to paleoclimatologists reading the isotopic record of past temperatures. Some will go to ancient DNA specialists. Some will go to paleobotanists identifying the pollen types in each layer, constructing a picture of the vegetation that existed at each moment in the record. Some will go to microbiologists examining the microbial communities, the living organisms that persisted through the cold, dormant and waiting, and that begin to stir as soon as the sample warms. The work of permafrost science is slow, cold, and extraordinarily detailed. It requires an unusual combination of skills, the physical endurance and practical expertise needed to work in Arctic field conditions, and the painstaking laboratory technique required to extract meaningful information from frozen ground. It requires patience of a particular kind, the willingness to spend years building a data set that will only reveal its meaning when viewed alongside many other data sets, to collect measurements that will not be interpreted for a decade, to work on a timescale that is fundamentally incompatible with the urgency that contemporary life generally demands. There is something I find deeply admirable in this. The permafrost scientists I have read about and encountered work with a kind of unhurried seriousness that seems appropriate to their subject. They are measuring something that moves slowly, and they move slowly with it. They are reading an archive that was laid down over millions of years, and they read it with corresponding care. The most important insights in permafrost science have often come not from a single brilliant experiment, but from the patient accumulation of measurements over time. Temperature records maintained at the same location for 30 or 40 years, each year's data adding a new line to a graph that only becomes meaningful in aggregate. This is science as an act of sustained attention. Science as a form of patience that mirrors, in its own way, the patience of the cold.
The permafrost research community is also, in many ways, a community in genuine conversation with the indigenous peoples of the Arctic. A conversation that is sometimes awkward and historically fraught, given the long history of Western science treating indigenous knowledge as anecdote and indigenous peoples as informants rather than as partners, but that is increasingly genuine and productive. Indigenous elders in Alaska, in Siberia, in the Canadian North have been observing permafrost change for decades before the scientific instruments confirmed it, describing shifts in landscape, in drainage, in the behavior of the ground under their feet that the permanent record now corroborates. The integration of this long-term observational knowledge with the instrumental records of recent decades is giving scientists a richer and more complete picture of how the permafrost is changing than either tradition could provide alone. It is, when it works well, exactly the kind of knowledge-making that the complexity of the problem demands.
There is a question underneath all of this that I want to bring to the surface before the night deepens fully, and you let go of everything, including the thread of this narration. It is a question about what the permafrost means, if meaning is a category that applies to things like frozen ground. The permafrost does not know that it is extraordinary. It does not know that it holds the bodies of animals from the Pleistocene, or that its carbon content is climatically significant, or that scientists travel enormous distances at considerable expense and discomfort to drill into it and read its layers. It does not know that the indigenous peoples who have lived above it for thousands of years have built their architecture and their food systems and their understanding of the seasonal world around its presence. It does not know that it is thawing, or what the consequences of that thaw are likely to be. It only knows, if knowing is the right word, and it probably is not, how to be cold, how to hold, how to maintain the conditions under which everything within it remains exactly as it was when it was sealed. This is not intelligence, it is not intention, it is not patience in any sense that requires awareness. It is simply the behavior of matter under certain conditions, behavior that, viewed from the outside, from the vantage point of a warm-blooded, time-conscious human being lying in a comfortable bed in whatever part of the world you occupy tonight, looks uncannily like something more than matter, looks like memory, like loyalty, like the keeping of a promise that was never explicitly made. I think about the mammoth foal who died 42,000 years ago in the cold mud of the Siberian tundra, and who was found last century with the last thing she ate still in her stomach. The cold that kept her did not care about her. There was no care involved. There was only the absence of warmth and the reliable, impersonal operation of physical law. But the result, to the human minds that found her, examined her, read her last meal, looked at the soft pads of her newborn hooves, was indistinguishable from an act of careful, faithful keeping. The permafrost held her with the same reliability it holds everything, which is to say without preference or selection or intention, but also without any failure or forgetting. 42,000 years of perfect keeping. This is, if you think about it from the right angle, which I recommend doing from a horizontal position with your eyes closed and your breathing slow, a rather comforting thought. Not because the permafrost cares. It does not care, but because the universe is full of reliable processes, and reliability is a form of trustworthiness, even in the absence of intention. And the ground beneath the frozen north has been trustworthy in this particular way for longer than the human imagination can really grasp. Something vast and old and impersonal has been keeping the record of this planet's past with extraordinary fidelity. It kept it through the ice ages and the warm interglacials. It kept it through the arrival and spread of our species and the transformation of the world's surface that followed. It has kept it through all of recorded history. And right now, tonight, while you are warm and still, it is still keeping it. The cold is still down there. The archive is still intact in its unreached depths, even as its margins begin to change.
The mammoth that has not yet been found is still waiting in its frozen suspension. The seeds from the Pleistocene that have not yet been tested are still alive in the dark below the tundra. The ancient atmosphere, sealed in the bubbles of ancient ice, is still preserving its record of how the world breathed before we changed it.
There are places in the world where you can go underground into the permafrost itself, not through a drilled core hole, not the centimeter-wide cylinder that scientists extract, but through actual tunnels, human-scaled passages bored through the frozen earth, in which you can stand and look at the walls and understand, in a way that reading about it cannot quite convey, what the permafrost actually is. One of these places is a research tunnel near Fairbanks, Alaska, operated by the U.S. Army Cold Regions and Engineering Laboratory. It was originally dug in the 1960s, extended in later decades, maintained as a research facility, but also as a kind of permanent underground exhibition of the permafrost itself. The tunnel descends into ground that has been frozen for at least 14,000 years, and the walls of the tunnel, rough and irregular, carved directly through the frozen earth, expose cross-sections of the permafrost layers as they were deposited across that timescale. Standing in that tunnel, not reading about it, but actually standing in it, in the cold that registers several degrees below zero and that hits you immediately and completely when you descend from the warmth of the Alaskan autumn above, you see things that do not quite fit any prior mental image of underground space. The walls are not rock. They are not earth in any familiar sense. They are a mixture of frozen soil and ice in structural arrangements that catch the light of the tunnel lamps in ways that are unexpectedly beautiful. There are thin horizontal seams of pure, clear ice, relict ice wedges, formed over centuries of repeated freeze-thaw cycles that show up in the tunnel wall as lines of transparency in the otherwise opaque frozen earth. There are darker bands corresponding to periods of greater organic deposition, ancient soil layers, the remnants of tundra surfaces from different periods of the past, and occasionally, frozen into these layers, visible in cross-section in the wall, there are remains, plant material, insect remains, the occasional bone fragment from an animal that died and was sealed into the permafrost at some point in the 14,000-year span the tunnel represents. It is, in the most immediate and physical sense, an underground library, not a metaphorical one. The layers are the pages, the dark bands are the chapters, the frozen remains embedded in them are the illustrations. The cold that fills the tunnel is what has kept the library intact. Not air conditioning, not controlled storage, not any human intention, but simply the ground itself, maintaining the temperature it has maintained continuously since the last ice age. I want you to imagine being in that tunnel, not urgently, not as an exercise in active imagination that requires effort from you, because the whole point of tonight is that nothing should require effort, but gently, in the way that an image comes when you are almost asleep and your mind is making its own quiet associations. You are standing in a narrow tunnel in frozen earth, surrounded by walls that are the physical substance of 14,000 years. The light from the lamps is yellow and soft. Your breath makes small clouds in front of you because the air is far colder than your body. The silence is complete and specific, not the silence of an empty space, but the silence of a space that is full of something that does not make sound, full of the past, frozen and held, patient and dark and cold, stretching in every direction around the small warmth of you. There is nowhere more still than underground, nowhere further from the ordinary urgency of the surface. The ground above you and around you and below you has not moved in any meaningful way since it froze. It will not move until it thaws.
For now, and for all the time you are imagining yourself standing in it, it is exactly as it was, exactly as it has been, exactly as it will continue to be until the conditions change, which they have not yet, not here, not in this depth and darkness where the cold is still absolute and the archive is still intact.
Halfway through a night like this, and it is, give or take, roughly the middle of the journey we set out on together, there is a particular quality of attention that settles in. You have heard enough to know the territory. You are familiar now with the scale and the character of the thing we have been exploring. The details are not new anymore. They are becoming a landscape you have spent time in, a place with familiar features and a known feeling. And in that familiarity, in the way a room you have been sitting in for a while loses its initial strangeness and becomes simply the room you are in, the permafrost loses some of its foreignness and becomes simply a fact about the world you are part of. This is, I think, what good narration can do for large and difficult things. Not make them smaller or easier or more manageable in any practical sense. The permafrost is not smaller because we have spent time thinking about it, and its carbon stores are not less significant because we understand them a little better. But it can make them present. It can bring something that exists outside the normal field of attention into that field, not as an alarm or a demand, but as a kind of company. The vast cold under the northern ground, patient and old and utterly indifferent to our presence, has been there all along. It has not needed us to know about it in order to do what it does, but knowing about it changes something in the quality of the world as experienced from the inside of a human life, adds a dimension, deepens the picture, makes the planet feel more layered and more interesting and more itself. There are people who find that large geological and ecological facts make them feel small in an uncomfortable way. The vastness of the timescales, the impersonality of the processes, the indifference of the physical world to human concerns, all of this can be experienced as a kind of diminishment, as a reminder that we are brief and the Earth is long, and what we do in our few decades here does not add up to very much in the accounting of deep time. I understand that feeling, but I do not share it, and I want to offer you an alternative way of sitting with the scale of what we have been discussing tonight, because I think there is one available that is more honest and more useful. We are, as far as we know, the only part of the universe that is aware of the permafrost's existence. The cold has been accumulating its archive for millions of years, and in all that time, the archive did not know it was being made, and no one knew it was there to read. The woolly mammoths and the cave lions and the Pleistocene horses and the ancient flowers and all the ancient carbon, none of it knew it was remarkable. None of it required an audience. But we are the audience. We are the species that evolved enough complexity to drill into the frozen ground and read the layers, to find the foal and understand the significance of the soft hooves, to grow the ancient seeds and watch the Pleistocene flowers bloom in a modern greenhouse. We are the ones for whom the archive is legible. And that legibility, the fact that the record laid down over millions of years by unintelligent physical processes happens to be readable by beings capable of appreciating what it means, seems to me not diminishing but extraordinary. We are the universe becoming aware of what it has been keeping. The cold stored it. We found it. Both things are necessary for the story to exist.
The permafrost is not just a phenomenon of land. Its influence reaches into the sea and into the atmosphere and into dimensions of the planetary system that seem, at first consideration, very remote from the idea of frozen ground. Beneath the Arctic Ocean, where the continental shelves, the broad, shallow underwater plateaus that extend outward from the Arctic coastlines before dropping into the deep ocean, were exposed as dry land during the glacial maxima when sea levels were lower, permafrost formed. When sea levels rose again as the glaciers retreated, these coastal permafrost zones were not immediately thawed. The ocean is cold, and the sediment retained its frozen character for thousands of years after the seawater covered it. The result is a vast zone of submarine permafrost, frozen ground lying beneath the seafloor, as much as a kilometer thick in some locations, extending across enormous areas of the Arctic Ocean. This submarine permafrost is less well studied than its terrestrial counterpart, in part because it is harder to reach and harder to drill, and in part because its behavior is more complex, subject to the warming effect of the ocean water above rather than the atmosphere, and subject to pressure changes that affect how ice behaves at depth. But it is warming. The ocean is warming, in the Arctic, faster than anywhere else on the planet, a phenomenon known as Arctic amplification, where the loss of sea ice and the resulting change in how the ocean absorbs and reflects solar energy creates a positive feedback that accelerates warming in the region. The submarine permafrost is responding to this warming. In some areas of the shallow East Siberian Arctic shelf, one of the largest submarine permafrost zones in the world, researchers have measured elevated methane concentrations in the water column above the seafloor and elevated concentrations in the air above the water, suggesting that the submarine permafrost is releasing methane into the ocean and from there into the atmosphere. The debate about how significant this submarine permafrost methane is and how quickly it is likely to increase is active and ongoing in the scientific literature. There are researchers who consider it a serious near-term climate concern, and researchers who consider the current rates low enough that it should not divert attention from other, more certain emission sources. The honest answer, at present, is that we do not yet know. The monitoring of submarine permafrost is in its early stages. The data sets are short. The uncertainty is genuine. This is not a comfortable place for a person trying to understand the situation, but it is the honest one, and there is something to be said for understanding exactly where the edge of current knowledge lies, rather than smoothing it over with false certainty in either direction. What can be said clearly is that the permafrost system, terrestrial and submarine, Arctic and subarctic, deep and shallow, is a single interconnected system, and that changes at its margins are propagating into its interior in ways that were not anticipated even a decade ago. The Arctic is warming faster than any other region on the planet. The permafrost is the substrate of the Arctic. The substrate is changing. Let that thought settle, gently, not as an alarm, not as an invitation to anxiety, which would be exactly the wrong kind of company for sleep, but as a fact, a very large fact about a very old system, delivered in the spirit of honest information rather than urgency. The ground is changing. The cold is retreating from its edges while its depths remain intact. The archive is being opened slowly at its margins. The center is holding, for now, for a long time to come. And while it holds, it keeps.
I want to talk, before we come to the close of tonight, about patience, about what real patience is, as opposed to the pale imitation we manage in our own lives. Human patience, the kind we praise in others and aspire to in ourselves, is usually a matter of waiting, of restraining the impulse to act or speak or demand resolution, of enduring a delay between wanting something and receiving it. It is an achievement of will. It requires effort and deserves credit. When we say a person is patient, we mean they have managed their own urgency, held themselves steady against the pull of desire or frustration, stayed calm in the face of the gap between what they want and what is currently happening. The permafrost does not have urgency. It does not have desire. It does not have a will to manage or an impulse to restrain. In this sense,
calling the permafrost patient is straightforwardly wrong. Patience implies the management of something that wants to move, and the permafrost does not want to move. It simply does not move, because the conditions that would cause it to move have, for most of its existence, not been present. And yet, there is something about the sheer duration of its stillness, the scale of the waiting, the completeness of the holding, that does something to the concept of patience when you sit with it long enough. The fall waited 42,000 years to be found. The seeds waited 30,000 years to grow. The carbon of the Pleistocene has been waiting, in some portions of the permafrost, for over 1 million years to be released back into the cycle it was removed from. None of this waiting was conscious, none of it was difficult, none of it required any effort at all. But the result of all that effortless, impersonal, patient holding is what exactly? Is it not in some sense the most comprehensive and reliable record that the natural world has produced? Is it not in some sense a kind of faithfulness? The permafrost has been faithful to the conditions that froze it in a way that no human institution, no library, no archive, no tradition has ever approached. Not because faithfulness was intended, but because the conditions for infidelity, warmth, thaw, the return of life to the carbon, have simply not been present. When you lie down in the dark tonight, in your warm bed, in your warm room, in whatever corner of the warm surface world you occupy, there is something happening a long way from you in every direction, in Siberia and Alaska and Canada and the Tibetan Plateau, and beneath the shallow Arctic Sea, that is, by any measure available to human experience, extraordinarily patient, extraordinarily faithful, extraordinarily still. It is still down there right now. It will be still when you wake. The layers of the Pleistocene will still be in the ground. The frozen folds and the ancient seeds and the sealed Pleistocene atmosphere will still be waiting. The cold will still be holding, as it has held, as it will continue to hold in its deep, intact heart, for timescales that make the entire span of everything you will ever do or know or care about seem very brief indeed. This is not a small comfort. It sounds like it might be, and I understand if at first the thought of a very large, impersonal, frozen system seems like an unlikely source of consolation. But lie with it for a moment, because I think it earns its place. The world is older than our troubles. The ground is more patient than our urgency. The universe has been keeping records, in its own indifferent way, since before we existed to read them. And the records are still there, still intact, still waiting for our continued careful attention. We are not the first story this world has told. We are not the last one. And the ground beneath the northern sky, cold, old, vast, faithful, patient beyond any patience you or I have ever managed, is not indifferent to us in any cruel sense. It is simply larger. It has simply been here longer. It is simply doing with perfect reliability what it has always done, holding, keeping, preserving the record for whatever comes next. We began tonight by going underground. We went into the frozen earth, into the permafrost, into a place that exists right now under a quarter of all land in the Northern Hemisphere, that has existed continuously for periods of time so long they resist comprehension, that holds within its dark and cold interior the remains of animals not seen alive in 10,000 years, seeds that remember how to grow after 30 millennia, the atmospheric record of a planet breathing across ice ages and warm periods, and all the long, slow variations of a system so complex that we are still, with every instrument we have built, only beginning to read it. We traveled through the landscape above the frozen ground, through the patterned tundra and the pingos and the drunken forests and the Thermokarst lakes, through the geometries that cold makes when it has been working on a landscape long enough. We met the peoples who have lived above this frozen ground for thousands of years and who learned its properties in the way that long attention teaches, not by measuring, but by living alongside, not by extracting data, but by depending on what the ground provided and respecting what it required. We looked at the carbon held within the permafrost, the vast quantity of ancient organic material locked in cold and waiting in a suspension that has persisted since before our species walked upright. We looked at what happens when that suspension begins to end, the slow exhale of ancient carbon into the modern atmosphere, the feedback that connects the frozen past to the warming present in a loop whose full implications we are still working to understand. And we ended up, as I hoped we might, somewhere more fundamental than any particular fact about permafrost. We ended up with the idea of patience, real patience, impersonal, effortless, so complete as to be functionally indistinguishable from faithfulness, so old as to make all our human urgencies seem briefly, quietly, kindly small. There is nothing you need to do with this tonight. There is no action it requires. There is no appropriate response other than the one you are already in the process of giving, the slow relaxation of the body into the support of the surface beneath you, the gradual loosening of the grip that the day has had on your thoughts, the quiet beginning of the surrender that sleep is. The permafrost does not need you to think about it in order to keep doing what it does. It kept the foal for 42,000 years without any of us knowing about it. It will keep the next thing it keeps with the same absolute reliability. Tonight, you are warm. The world below you is old. The archive is intact. The cold is still holding in the depths where warmth has not yet reached, in the dark below the tundra, below the roots of the last trees, below the seasonal frost that comes and goes with the year, down in the permanent, patient, faithful cold that has been doing this since long before there was anyone to notice, and will continue doing it in the parts of it that remain, long after tonight has become a memory you no longer quite recall. The permafrost has been keeping its record through everything, through the ice ages and the warm periods and the rise and fall of 100 million years of ecosystems, through the arrival and the ingenuity and the unintended consequences of our species, through all the nights that have ever been slept above it by every creature and every person who ever lay down in the dark in the northern world and let their breathing slow. It will keep its record through this night too. Rest now. Let the cold be cold, and the ground be deep, and the patience be as vast as it is, which is vastly more than enough. Let the thought of something that enormous and that still settle into you the way cold settles into the earth, not all at once, but slowly, deeply, without announcement, from the surface down. You are warm, the world is old, the frozen ground is keeping its record. Sleep well.
There is a world that no living person has seen and that no written record describes. It existed on this planet for the better part of 2 million years, from roughly 2.6 million years ago to approximately 11,000 years ago, though the dating is approximate and the transitions were gradual rather than sharp. It is called the Pleistocene, and by a remarkable coincidence of geological timing, it is the epoch during which our species came into existence, became recognizably human, developed language and fire and social complexity, and all the cognitive architecture that makes us what we are. The Pleistocene is, in the most fundamental sense, the world we were built for, the world our bodies were shaped by, the world our instincts still partly expect. The Pleistocene was characterized by ice. Not continuously, the epoch contained many cycles of glaciation and warming, of ice advance and retreat, of sea level rise and fall.
but the general character of the Pleistocene was colder than the world we now inhabit, with more extensive ice sheets, lower sea levels, and a distribution of ecosystems very different from the one that currently exists. The tropical and subtropical zones were narrower, the temperate zones were colder and drier, and across vast portions of the Northern Hemisphere, across Eurasia and North America and the Arctic regions, there existed a biome that no longer exists anywhere on the planet's surface today. A biome that is sometimes called the Mammoth Steppe or the Pleistocene Steppe, and that was, in terms of sheer geographic extent, one of the largest ecosystems the modern world has ever seen. The Mammoth Steppe was a grassland, not a tropical grassland or a temperate meadow, but a cold, dry, wind-swept expanse of grasses and sedges and low herbs that stretched from the shores of Western Europe all the way across Eurasia to the Pacific coast of Alaska, a continuous belt of grassland ecosystem covering enormous areas of what is now tundra or boreal forest or ocean. The latter because sea levels were lower during glacial maxima and the shallow continental shelves were exposed as dry land. This ecosystem was extraordinarily productive, not lush, not warm, not visually dramatic, but biologically dense in the way that the great African savannas are today, supporting herds of large grazing mammals at densities that would seem impossible to a modern eye confronted with the same landscape. Mammoths, woolly rhinoceroses, bison with horns spanning 2 meters, wild horses in herds that stretched to the horizon, giant deer with antlers so large they seem impractical for any animal that had to move through them, cave hyenas and cave lions and dire wolves and short-faced bears, all the great predators that the prey base supported. And under all of it, through all of it, the permafrost, the frozen ground that held the moisture near the surface, that kept the roots of the grasses from going too deep into the frozen substrate, that maintained the cold and dry conditions that the Mammoth Steppe required. All of this is gone from the surface, that is. The Mammoth Steppe vanished as the Pleistocene ended, not suddenly, but over several thousand years of warming and changing precipitation patterns that transformed the grassland into the tundra and boreal forest of the modern world. The herds dispersed or went extinct. The megafauna of the Pleistocene, the mammoths and rhinos and giant deer, disappeared, caught in the combination of a changing climate and the expanding presence of a new kind of predator, armed with projectile weapons and a tendency to follow prey over very large distances without tiring. The old world ended. But it did not disappear entirely. It went underground. The permafrost sealed the Mammoth Steppe into itself. The grasses, the animals, the insects, the microbes, the chemical record of the atmosphere, and the biological record of the ecosystem, and kept it in the dark and the cold and the silence below the changed surface of the world. When we drill into the permafrost today and find the remnants of that lost world, we are not finding fossils, we are finding the Mammoth Steppe, the actual thing, preserved with a fidelity so complete that the pollen of its flowers can still be identified by type. The stomach contents of its animals can still be read. The ancient DNA of its organisms can still, in many cases, be sequenced and compared to modern relatives. The Mammoth Steppe is down there, right now, all of it, that died and was sealed into the cold rather than decomposing on the surface. Beneath the Siberian tundra, beneath the Alaskan coastal plain, beneath the shallow sediments of the East Siberian Arctic shelf, where the sea level rise of the Holocene covered the old land surface with seawater. The frozen record of an entire lost world, laid down in cold and held in cold, waiting for the cold to continue, or, as is now happening at its margins, for the warmth to release it back into the cycle from which the permafrost removed it. There is something about knowing this, about knowing that the last world that preceded ours is not merely a historical memory or an archaeological reconstruction, but a physical, preserved, retrievable thing underground that shifts the ground slightly under the normal assumptions we make about past and present, about what is gone and what remains. The mammoth steppe is gone from the surface of the world. It is present in the frozen record below it. These two things are simultaneously true, and the second one does something strange and interesting to the first, makes gone not quite mean gone, makes lost not quite mean lost, makes the past seem less irrevocably past when its physical substance is still there, still held, still waiting in the dark below the changed surface.
Every ecosystem on Earth is a conversation between organisms and their environment, between producers and consumers, between the physical conditions of a place and the life those conditions have shaped, and that in turn shapes them. Most of these conversations are too slow and too complex for a human to follow in real time. They unfold across centuries and millennia and geological periods, in the language of evolution and ecology, in a vocabulary that requires instruments and patience and long records to interpret. The permafrost is part of one of the longest and most consequential of these conversations, the conversation between life and the carbon cycle, between the living world and the chemistry of the atmosphere, between what grows and dies and what is preserved and what is returned. On timescales of millions of years, life on Earth has been moving carbon from the atmosphere into the ground. Plants take carbon from the air and build their bodies from it. When they die without being fully decomposed, when they are buried in conditions that prevent the normal return of their carbon to the atmosphere, that carbon accumulates. This is how coal and oil and natural gas formed. This is how the permafrost carbon formed. This is how, over geological time, atmospheric carbon dioxide concentrations have changed, not randomly, but in part as a function of how much life is growing and dying and being preserved versus decomposing and returning its carbon to the air. The permafrost is a temporary participant in this conversation. It is a pause, a long pause, so long by human standards that it seems permanent, but not permanent by the standards of geological time. The carbon stored in permafrost is not stored forever. It will return to the atmosphere when the conditions that maintain it, the cold, change. It has returned before, during previous warm periods. It will return now, as the current warm period is amplified by our own additions to the atmospheric carbon load. But before it returns, and this is something worth holding on to, it has been sequestered. For tens of thousands, and in some cases hundreds of thousands of years, the permafrost has been holding this carbon out of the active carbon cycle. During the cold centuries of the Little Ice Age, when the permafrost was more extensive and more deeply frozen than it is today, it was holding more. During the warm periods of the Holocene, it was holding a little less. The conversation continues. The carbon breathes in and out of the system on timescales that dwarf our ability to observe them directly, and the permafrost is one of the most important participants in that conversation. A vast, cold, patient lung that draws in carbon during cold periods and releases it during warm ones. We are, right now, in the release phase. The long breath in is becoming a breath out. This is not catastrophic in geological terms. The Earth has breathed this carbon out before and absorbed it again. But the timescale on which it is happening is, by geological standards, very fast. The difference between a gradual geological warming over tens of thousands of years and an abrupt human-forced warming over a few centuries is the rate of change. The carbon cycle can adapt to gradual change.
It has more difficulty adapting to abrupt change, and the ecosystems that depend on it, including all human civilizations, have even more difficulty because they evolved in a relatively stable climate and are not well suited to rapid transformation. This is the conversation that we have, unintentionally, joined. Not as equal participants, we do not have the geological patience of the permafrost, the slow reliability of the carbon cycle, the measured responsiveness of a deep Earth system. We are brief and fast and capable of very large changes in very short times. And we have altered the conditions for a conversation that was proceeding on its own, in its own good geological time, long before we arrived. The permafrost is responding to our presence in the conversation, not because it knows we are here, not because it is reacting to us as such, but because we have changed the temperature, and temperature is the one variable that determines whether the permafrost holds or releases, whether the cold remains or retreats, whether the ancient carbon stays below the surface or rises into the air we breathe.
It is very late where you are, or very early. The distinction between late and early stops mattering at a certain point in the long dark of a night spent listening, because the night itself becomes a single continuous presence rather than a sequence of moments with a clear direction. You are simply in it, the dark, the quiet, the particular stillness that comes in the hours when the rest of the world has mostly stopped. Underneath that stillness, underneath the floor of wherever you are, through all the soil and subsoil and rock between you and the deep interior of the planet, there is the Earth, just the Earth, doing what it has always done, rotating, maintaining its temperature gradient from its hot core to its cold surface, cycling water from ocean to sky to land and back again, moving its tectonic plates at the pace of a growing fingernail, carrying its various passengers, the living ones, the recently dead ones, and the long frozen ones in the Arctic deep, through another night in its 4.5 billion year existence. The permafrost is out there right now, in the way that the ocean is out there, and the mountains are out there, and the deep sky is out there, present and vast and proceeding in its own way regardless of whether anyone is noticing. The Siberian permafrost is in its own night too, several hours shifted from yours, lying under a landscape of frozen rivers and dark pine forests and wide flat tundra plains that will not see meaningful light again for months. The Alaskan permafrost is in its own night too, under mountains and coasts and boreal forest and the thin winter star fields of the subarctic sky. All of it cold, all of it still, all of it doing what it has done for longer than anything about human civilization has existed. There is a quality to thinking about this at night, specifically in these hours, that is different from thinking about it in daylight. In daylight, the world is immediate and visible and full of the continuous activity of living things. It is hard to feel the depth beneath the surface when the surface is so present. But at night, when the visual world has receded and the activity has quietened and the sense of the world's continuous busyness has softened, the depth becomes more accessible. The old things are easier to feel. The ground beneath you seems more present, more specific, more worthy of attention than it does in the daytime when the surface is claiming all of it. The permafrost is a night landscape in its depths, even when the surface above it is in the fullest Arctic summer light. The cold below the active layer does not respond to the season in any short-term way. It is perpetually in its own long winter, its own geological dark, undisturbed by the rotation of the planet or the tilt of its axis that produces your night and mine. It knows a different kind of time, a time measured in the accumulation of organic layers, in the slow advance and retreat of ice fronts, in the geological movements of continents, a time in which a human night is not even measurable,
too brief to appear in the record, too small to register against the scale of what the permafrost keeps track of. You are very small against that scale. This is true, and I think it is important not to shy away from it. But small is not the same as insignificant, and brief is not the same as meaningless. The candle in a dark room is small. The candle does not go into the dark unchanged. Something about the room is different for the brief presence of the light. Something about the permafrost is different for the brief presence of the beings who noticed it and named it and drilled into it and read its archive and began, however incompletely, to understand what it was keeping and why it mattered. The keeping goes on. Your noticing of it tonight in the dark adds something small and genuine to the sum of the world's awareness of itself. And then you sleep, and the keeping goes on without you, and the cold holds what it holds, and the night passes over the surface of the world as it has always passed, leaving everything below unchanged, everything above briefly illuminated, briefly awake, briefly warm. Sleep well. The ground is still there. The cold is still keeping. The archive is still intact.
I want to spend a little more time with the animals of the Pleistocene because they deserve it, and because the permafrost has given us enough of them that we can speak about them not as abstractions, but as individuals, as specific creatures who lived specific lives and died specific deaths, and were held with such care in the frozen ground that we can read the details of those lives and deaths from their preserved remains. The woolly mammoth is the most famous, as I have said, but it is worth lingering in that familiarity rather than passing through it quickly. What did a woolly mammoth actually look like, in life, in motion? The permafrost specimens give us something we cannot get from bones alone: texture, color, proportion. The fur was reddish-brown to dark brown, coarser on the outer layer and softer and denser on the inner layer, which provided the insulation necessary for Arctic winters. The skin was thick and heavily creased around the neck and legs. The ears were small, much smaller than modern elephant ears, because large ears radiate heat, and in the Arctic, keeping heat was the priority. The famous curved tusks were not merely ornamental, but functional, used to sweep snow aside to reach the grasses and sedges below, used in social interactions and possibly in combat, used in ways that left characteristic wear patterns that we can still read on the tusks of permafrost-preserved specimens. The baby mammoth Chroma, found in northeastern Siberia in 2008, was roughly 3 months old when she died, approximately 50,000 years ago. She was found in a layer of frozen sediment beside a river that had been gradually eroding the bank for decades before her body appeared. Her trunk was still flexible when she was first examined. Her fur, though partially damaged by the slow thaw that had exposed her, retained enough character to tell the researchers that she was probably lighter in color than adult mammoths, the pale, woolly coat of a young mammal, not yet the darker adult fur. She still had her baby teeth, the small temporary teeth that mammal calves use before the larger adult dentition develops. She had been alive, apparently healthy, in a world that had not changed in any way meaningful to a 3-month-old mammoth. And then she died, quickly, and was sealed into the cold, and waited 50,000 years, and was found. There is something about the specificity of Chroma's babyhood, the baby teeth, the pale fur, the flexible trunk, that makes the timescale feel different from when we are dealing in geological abstractions. A baby is a baby. It is recent, specific, still in the process of becoming. The 50,000-year separation between her brief life and the hands that found her seems to compress in some way when you hold the image of a 3-month-old mammoth, still woolly, still small, still not yet quite the creature she would have grown into. The permafrost kept her in that almost becoming. It kept her 3-month-oldness intact across a span of time that includes every single human event we have ever recorded or imagined, plus 49,000 years before those events began.
The cave lions are equally specific and equally quietly astonishing. 2 cave lion cubs found in Siberian permafrost in 2015 and subsequently named Uyan and Dina were approximately a week old when they died, approximately 28,000 years ago. They were found together, curled in the position of sleeping kittens, their bodies in contact with each other the way newborn siblings stay in contact for warmth. Their eyes were sealed, as newborn lions' eyes are. Their claws were retracted, as newborn cubs' claws are. Their whisker pads showed the follicles of whiskers that had not yet fully grown. In photographs taken at the moment of their discovery, they look like they are asleep, very old, very cold, and very asleep. The look on their faces, if you can say a frozen face has a look, is the undisturbed peace of animals who did not suffer long, who were kept exactly at the moment of that undisturbed sleep, and who have been in that same moment ever since. Cave lions are extinct. Their living relative, the African lion, exists on a different continent in a different ecosystem under very different conditions. But the permafrost has given us individual cave lions at the moment of their births, not species reconstructions, not skeletal composites, but individuals with their particular expressions and their particular fur and their particular postures in the cold. The permafrost has made the cave lion specific in a way that no fossil ever could. It has given it back its individuality. This is what I mean when I say the permafrost is an extraordinary kind of archive. It does not preserve categories. It does not preserve species profiles or average individuals. It preserves specific things, this foal, this cub, this flower, this last meal, with all their particularity intact. In a world where the past generally survives only as the generic and the averaged and the reconstructed, the permafrost insists on the specific. It says this one, this individual, this moment, this exact expression on this exact face at the exact instant of a death that happened 28,000 years ago. It refuses the abstraction that time usually imposes on all things.
The permafrost is not only a phenomenon of the high latitudes, it extends in a different form and under different conditions into the high altitudes of mountain ranges well to the south of the Arctic Circle. The Tibetan Plateau, the highest and largest plateau on Earth, covering an area roughly 4 times the size of France at an average elevation of over 4,000 meters, has permafrost. Not permafrost as ancient or as deep as the Siberian permafrost, because the Tibetan Plateau has not been continuously frozen for the same immense geological periods, but permafrost nonetheless, frozen ground that shapes the landscape and the hydrology and the ecology of the high plateau in ways that are profound and only beginning to be fully appreciated. The Tibetan Plateau is sometimes called the water tower of Asia because the rivers that flow from it, the Yangtze, the Yellow River, the Mekong, the Salween, the Brahmaputra, the Indus, and the Ganges, provide water for something in the range of 2 billion people in the countries downstream. The water from these rivers comes from multiple sources: the seasonal snowfall, the glaciers, and the permafrost. The permafrost contribution is less visible than the glaciers and less immediately understood by most people, but it is hydrologically significant. Permafrost acts as a water storage and regulation system. In the warm months, the surface of the permafrost thaws, and the water from snowmelt is held near the surface rather than draining quickly through the soil, maintaining the wetlands and bogs and high-altitude grasslands that are characteristic of the plateau. In the cold months, the surface refreezes and the water is stored until the following year. As Tibetan Plateau permafrost thaws, and it is thawing under the influence of a warming that is particularly intense at high elevations, this regulatory function changes.
In the short term, thawing permafrost can release stored water, increasing river flows. In the longer term, as the permafrost disappears and the storage function is lost, the high-altitude wetlands that depend on permafrost-held moisture begin to dry out. The grasslands that have supported pastoral communities on the Tibetan Plateau for thousands of years begin to change their character. The great rivers that flow from the plateau begin to show greater seasonal variability, higher in summer, lower in winter, as the permafrost's moderating influence on the water cycle diminishes. The pastoral communities of the Tibetan Plateau have been noticing these changes. The nomadic herders who have kept yak and sheep on the high grasslands for generations are observing the same shifts that instruments are now measuring: the drying of seasonal wetlands, the change in the character of the grassland, the appearance of erosion and desertification in areas that were previously stable. They are adapting, as such communities always have, but the pace of change is faster than the traditional practices were designed for. The permafrost beneath their feet, invisible and unnamed in their cultural vocabulary in the way it was unnamed in Western science until the 20th century, but known in its effects through generations of practical engagement, is becoming a different kind of ground. The Tibetan permafrost also holds an archive, though a younger and less extensive one than its Siberian counterpart. In the high plateau lakes and wetlands, sediment cores reveal the climate history of the plateau across the Holocene and into the late Pleistocene. The permafrost itself preserves plant and insect remains from past centuries and millennia. The archive is thinner here. The plateau was not always at its current elevation, and the permafrost has not been present for as long, but it is real, and it is being read by the same careful science that reads the Siberian cores. In the midnight sky above the Tibetan Plateau in the winter months, when the temperature at altitude drops to 40 below and the stars are sharp and close-seeming in the thin, dry air, there is a particular quality of stillness that people who have experienced it describe as unlike any other stillness they have known. The plateau is enormous and high and empty in a way that creates silence of a particular depth, not the silence of soundproofing, not the silence of a room with no audio, but the silence of a landscape so large and so cold and so unchanging that the small sounds of wind and distant animals seem to float in it like objects in a very clear, very cold fluid. The permafrost below that landscape, below the frozen grasses and the sleeping rivers and the ice-rimmed plateau lakes, participates in that stillness. It is part of what makes the place feel old and unmoving and beyond the scale of ordinary human time.
We have been a long time tonight, in the cold, in the dark below the northern tundra and the Tibetan Plateau and the Arctic Ocean floor, in the company of frozen things from a world that ended before our species had fully begun, in the presence of a patience so absolute that the concept of patience itself begins to seem inadequate as a description. I want to bring you back very gently to the room you are in, not away from the permafrost. It is still there. It will still be there when you wake. The cold is still holding, but back to the warmth of where you are, to the support of the surface beneath you, to the slow and reliable rhythm of your own breathing that has been accompanying all of this, and that is perhaps by now much slower and deeper than it was when we began. Notice, if you can notice anything at all at this point in the night, how heavy your body has become, how thoroughly the surface you are lying on has accepted your weight, how little effort is being required of any part of you, your hands, your feet, the muscles around your eyes, the muscles of your jaw that spend the whole day clenched against whatever the day requires. All of it has gone soft.
All of it has surrendered to the kind of gravity that sleep applies. Not the ordinary downward gravity of the waking world, but the deeper, more patient gravity of rest, which pulls not just your body toward the earth, but your attention toward the dark, toward the quiet, toward the deep and wordless interior of sleep, where no narration follows you and no story is required. The permafrost will hold its archive through your sleep. It will hold it through the morning that follows, and the day after that, and all the days and years and decades of your life, through whatever changes come to the surface of the world, and whatever remains the same. In its depths, where the cold is still absolute and the warming has not yet reached, it will hold with the same fidelity it has maintained since long before you existed. The foal will still be there, the seeds will still be viable, the ancient atmosphere will still be waiting in its bubbles of frozen ice. The ground is old and still and patient. You are warm. The night is deep. That is enough. That is for this night and this moment and this particular version of you lying in the dark, listening to the story of the frozen earth, entirely enough.